In this hands-on activity, we will do an experiment on how things fall. If something is falling freely, there's only one force acting on it, its weight. So Newton's second law tells us that its acceleration must just be the acceleration of gravity, or g. This is because Newton said that the acceleration is equal to the force, mass times g, divided by the mass, if the force and acceleration are in the same direction. For our hands-on activity, you will need some sticks of the same length and, if possible, the same material. We will attach some weights near one end of the stick. These could be stones or plasticine or whatever you have available. To do the activity, just try to balance the stick on one open hand, with the weight at either the top away from your hand or at the bottom near your hand. Which way is easier? And can you do it with your eyes shut? So that we can explain what is happening, we can try something else. Use two of these sticks, one with the weight at the top and the other with the weight at the bottom. Lean them over slightly and then let them go. Which one falls faster? The weights are falling, but they're not falling freely, as we saw was a condition for the falling motion we talked about at the beginning. In this kind of falling, the weights are rotating around the bottom of the stick as they fall. Because the motion here is not in a straight line, we cannot use Newton's second law for straight line motion, force equals mass times acceleration. Here we have to use Newton's second law for rotation, which says that torque, the moment of a force around an axis, is equal to the moment of inertia times the angular acceleration. Torque is just a force that makes something rotate rather than move in a straight line. The moment of inertia tells us how something resists rotation, just as mass resists moving in a straight line. We can see the effect of this when we look at a chimney or a wall falling over. It seems to fall much more slowly than if it fell straight down under gravity. If we calculate the acceleration of the stick around the point where it rests on the table or floor, we find that if the weight is near the bottom, the acceleration is much larger, so the stick moves faster as it falls. If the weight is at the top, we can control the stick much more easily because it accelerates more slowly. If the weight is at the top, our brain has more time to adjust the balance of the stick by moving our hand to compensate for the falling. Try to use the stick as a sword. Which is easier to use, the weight near your hand or the weight far away from your hand? This is for the same reason as before. The acceleration is higher for the same torque if the weight is close to your hand, so you can move the sword more easily. Now turn the stick over and let the weight hang. Which way, weight at the top or the bottom, gives a higher frequency, faster swing to the pendulum? This activity has been all about force, torque, acceleration and moment of inertia. We have seen that Newton's second law can be used for rotation as well as for straight line motion. When you let the students do the experiments by themselves, they will be able to use their eyes to balance the stick on their hand and their sense of touch to feel the effect of the moment of inertia. This helps them to understand the physics, hands-on and minds-on.